Hello, welcome to a new series, a new playlist on engineering mathematics. And this is very important for any engineer. Okay, so what I'm going to do is I'm going to cover various areas of mathematics which are applied to engineering. Now, mathematics you know is going to be required in electronics, in communication, in control systems, and DSP, and various fields of electronics where you know you want to design something, you might need mathematics, right? So it's very important to have a firm footing on mathematics. So let's get started. So I'm going to start with this session in the playlist, which is very basic mathematics, so that I don't leave anyone behind before I start the advanced topics. So let's do a basic mathematics. So first of all, I'm going to start with the numbers. Okay, so in numbers you have got numbers which are whole numbers. So these whole numbers are going to be negative integers, like let's say -3, -2, -1, 0, 1, 2, 3. So these are known as, and so on. So these are known as whole numbers. So they have got negative integers. So these are negative integers. And then you have got positive integers. Right? And then you have 0, which is neither negative nor positive. Now if I talk about anything which is greater than 0, not including 0, that would be called natural numbers. Right? So numbers, you know uh, numbers can be expressed also as fractions or decimals. So if they have a fractional part or a decimal part, so they would be fractional numbers or decimal numbers, right? And then there are basic operators on these numbers, right? So the basic operators are, first of all, is the bracket. So basically it changes the precedence of operation, right? Then there is order, right? So order is basically the exponent part of it. Then there is division, then there is multiplication, there is addition, and there is subtraction. So this is bracket or of division, multiplication, addition, subtraction. So this rule is known as BODMAS, and this is how your expressions are going to be solved, right? Whether it is integers or whether it's fractional numbers, you are going to follow BODMAS. So this is the precedence in which an expression would be solved. So let's start with fractions. Okay, so fractions are basically numbers which are expressed as ratios. So basically there is a numerator divided by a denominator. Okay. Now if numerator is greater than denominator, that means that this number is less than 1. So these are known as proper fractions. So proper fractions are nothing but where numerator is less than denominator. Correct. So these are known as proper fractions. Now in case the numerator is greater than the denominator, then they are called improper fractions. So where numerator is greater than denominator, so this is proper fractions, improper. So basically they evaluate to less than 1, and these evaluate to greater than 1, right? Okay, so that's that. So now let's see some examples. So let's say I want to add let's say I want to take two numbers, let's say 2 by 3. Now this 2 by 3 is a, because numerator is smaller than denominator, then it's a proper fraction. Now if it was 3 by 2, then it would be a improper fraction, right? So improper fraction can also be expressed as, let's say, if I divide by 2, so I have 1 and then the remainder is 1, so this is 1 1.5, so this is equal to that. So this is called mixed number. Okay, so let's do simple mathematics on addition, but before that we have to touch upon a topic like what is called HCF, or highest common factor. Highest common factor. Okay, so basically if there are two numbers, then what I want to do is I want to find out what is the highest common factor among them, right? So let's say I have got two or more numbers. So let's say these numbers are 12, 30 and 42, right? So how would I find the HCF? I would take 12, 30, 42 and I'll try to divide it. Is what's common between them? It can be divided by 2. So this becomes 6 and this becomes 15. This becomes 21. Now in this case I can also divide by 3. So this becomes 3 to 6, 3 5 15, 3 7 21. So now this is common between all these three numbers. So then HCF, so HCF is going to be equal to 6, right? And then there is another thing which is called least common multiple, or least common okay. So let's say if I have a number and a set of numbers and I want to find out the least common multiple, so how would I go about doing that? Okay, so let's say these three numbers are going to be 12, 42 and let's say 90, correct? So let's find out its HCF as well as LCM. Okay, so here everything is divisible by 2, so 2 6 12, 2 2s are 4, 2 1s are 2 and 45, right? Now this is still divisible by 3 again, 3 to 6, right? 7 3s are 21, 3 1s are 3, 3 5s are 15, correct? So up till now these two are common between them. Now from here you see that they are not divisible by anything, right? So now the HCF is going to be 6, but the LCM is going to be 2 into 3 into 2 into 7 into 50, right? Okay, so this is going to be 6, 12, 84, 84 into 15. Okay, so if I do 84 into 15, so it will be 5 4 is 20, 5 is 40, 41, 42, and then you have got 84, so you have got 6 and 8 plus 4 is 12, so answer is 1260. So LCM here is 1260, right? So now why did I cover LCM, HCF and LCM is, let's say if I want to add two numbers, okay, so 2 by 3, let's say 2 by 3 plus 4 by 7. Now the LCM of the denominators, in this case 3 and 7, is going to be 3, then it's going to be 7, and then it's going to be 21, right? So the answer is going to be 21, and 3 7 into 2 is 14, plus 7 3, see, was 12, right? So then this is going to be 26 by 21, so that evaluates to that, right? So let's take another example. Let's say I want to do 3 by 4 plus 7 by 16, right? So in this case 4 and 16, so 4 1 4 4 16, so the answer is LCM is 16. So in this case this is 16, then 4 multiplied by 4 is 16, so 4 into 3 is 12 plus 7, so that is going to be equal to 19 by 16, right? So this is how you are going to do add two fractional numbers. Now let's say I want to subtract the two numbers. Okay, so let's say I want to do 3 by 4 minus 7 by 16. So again we do the same thing. The LCM is 16. In this case 4 fourth is a 12 minus 7. This is going to be equal to 5 by 16. So this is going to be subtraction. Now let's say if I want to do multiplication, so it is 2 by 3 multiplied by 4 by 7. So in this case you see nothing cancels on numerator and denominators, right? So I have 4 to the 8, 7 is 21. So that's the answer. Now if I was to do the division of these numbers, if I was to do 2 by 3 divided by 4 by 7, then that can be written as 2 by 3 multiplied by 7 by 4. Now in this case 2 is common here, so the answer is 7 by 6. Correct? Right. So answer is 7 by 6. Now this can also be represented as 1 by 1 and 1 by 6. So that's the answer, right? So you see I can do a addition, I can do a subtraction, I can do a multiplication, and I can do a division. Now if there is a big expression, then I have to apply this rule. Okay, so first I will solve for brackets, second I will solve for order or exponent, third I will solve for division, fourth is multiplication, fifth is addition, and sixth is subtraction. So that's what I'm going to do. Now I can also express these fractions as decimals. So decimals are going to have a decimal and some things before decimal and after decimal. So for example a number like 57.95, right? So in this case, okay, so the answer so I can express this as a fraction. So what I will do is I can write this as 57.95 divided by, let's say 100. So if 5 is a factor which is common, 5 ones are 5, 5 ones are 5, 5 is 25, 5 nines are 45, right? And then 20. Now is this further divisible? The answer is no. So then this can be also expressed as this. So I can divide by 20. So it is 25 is 100. Then I am left with 159. Okay, then right. So 159 means it is 5 and 7, right? Okay, so that will be equal to 140, and then I'm left with 140, and then I'm left with 19 by 20. So that's the mixed number. Okay, so I can do decimal to fraction, and similarly if I divide, so let's take another example. So for example I can have 375, right? So this can be written as 375 divided by 1000. Now this will be equal to what? This is divided by 5, 5 7 is 35, and then 5 is 25, 5 2 is 10, 200. So again it is divisible. 5 1 is 5, 5 is 25, and then this one is equal to 5 4 is 20. Then still divisible. 5 3 is 15, 5 8 is 40. So the answer is 3 by 8. Correct? So this is how you can convert a decimal into a fraction. Okay, and then you can also convert fraction into a decimal. So if I divide 3 by 8, so that is going to be point. So 30, it is 24, 60, 56, 8 7 is a 56, 40, 8 5 is a 40. So we are back to decimal. Okay, so that's very simple. Okay, so the now another thing is, if there are finite number of digits after the decimal, then this is called terminating decimal. Now if it is infinite number, it keeps on continuing, then it is called non-terminating decimal, or a irrational number. Okay, so if this repeats, then it can be expressed. If it doesn't repeat, the digits don't repeat, then it is going to be a irrational number. Okay, so decimals can again be multiplied, divided, raised to power something, right? So you will still apply this BODMAS if you solve the expression. Now these fractions can also be expressed as percentage. So in what do you mean by percentage is in how many parts of 100, in 100 how many parts. So for example, if I say 5 by 8, so in 100 how many parts, right? So if I'll divide by this, so I have 8 5 4, so if I divide 5 by 8, right, so I'm going to have 0, 8 6 are 48, 20, 8 2 is 16.625, right? Now this is the decimal. Now how many parts in 100? So I would have to multiply this by 100 to convert into percentage, so it is 62.5%. So you understand that a percentage is basically nothing but a fraction which is multiplied by 100. So in 100 how many parts? So that's what you mean by fraction, or percentage, sorry. Now the next thing it comes to is order. Okay, so I will come to law of indices. So law of indices are very simple. So let's look at law of indices. Okay, now it will be very basic for a lot of people, but I just don't want to leave out some stuff because I want to build on basics. Okay, so law of indices, first law. So if I have a raised to n, and if I multiply with a raised to m, then this is going to be a n plus m, correct? Second, if I have a raised to n and then I again raise it to power m, then this will be a raised to n into m, right? Third thing, if I have a raised to 0, that will be 1. Fourth thing, if I have a raised to minus n, this will be same as 1 over a raised to n, right? Okay, and the final part, if I have a raised to n divided by a raised to m, this can be written as a raised to n minus m, right? So this is law of indices, and this is going to be in number of places it's going to be used. So anyways, we will come to that. The next thing which is there is okay, system of equations. So this brings in, okay, so system of equations. So here what happens is, if you have got so if you have got n variables or n unknowns, right, then I need n equations to solve them. So this will be called system of equations. Okay, so for example, okay, very easy. So for example, I have equation, it says 3x plus 4y is equal to 5, and then I have got 2x minus 5y is equal to minus 12. So this is a system of equations. Now if I have 3 variables, let's say z is also there, then I would have 3 equations to solve it, and these 3 have to be independent equations. So it's not that I can by using certain mathematics I can achieve one of the equations. So that would reduce the the order by 1. So I'll not be able to solve that. There will be no unique solution for that. Okay, so we will cover that when we cover matrices, but for now let's look at very simple stuff. Okay, to solve this, one of the easiest method is going to be this method of substitution. So 3x is equal to 5 minus 4y, right? So x is equal to 5 minus 4y by 3. Now if I substitute that, then it will be 2 into 5 minus 4y by 3 minus 5y is equal to minus 12, right? So then this would be equal to 10 by 3 minus, okay, so what will be there is 8 by 3 y minus 5y is equal to minus 12, correct? Okay, now I can, so there is only one variable in the equation which is y, so I can solve that. So I have minus 8 by 3, so 3 5 is 15 by 3, y would be equal to minus 12 minus 10 by 3. Okay, so basically minus 15 plus 8 is going to be 23 y, and 3 is a common factor, minus 36 minus 10, 46 by 3. So 3 is going to cancel. So I would have 46 minus 46 equal to minus 23y, or y equal to 2. Correct? Okay. So if y is equal to 2, then I'm going to substitute this 2 back in here. So it will be 5 minus 8 by 3. So this will be minus 1. So the solution is x equal to minus 1 and y equal to 2. So this is by by substitution I have solved a system of equations, right? So this is my system of equations. Now let us consider that there are 3 equations. Now the substitution is going to become difficult. So let's say x plus y plus z equal to 4, and then you have got twice of x, okay, minus thrice of y plus 4z is equal to 33, let's say, and 3x minus 2y, okay, minus 2z equal to 2. Okay, so now this is a classic problem where I can use a method of elimination, right? So what is the method of elimination? I can express this as a matrix. I can say 1 1 1, 2 minus 3 4, and then I have got 3 minus 2 and minus 2, right? And then I have got the solution here as 4 33 and 2. So whatever I do row operations, I'm going to do on the right hand side also. So I want to eliminate one by one, the elements which are below the diagonal. So I want to have only upper right triangular, upper triangular matrix I want to have. So if I multiply this entire equation by 3 and subtract from the third equation, so what would I have? I would have this as 0, and this is minus 5, and this is going to be minus 5 also, and then this is 2 minus 3 times of 3 4s are 12, right? So 12, 2 minus 12 is going to be minus 10, right? Okay, so the next thing is I'm going to again multiply the first equation by 2 and subtract from the second. So I'll have 0 here, and then minus 5 here, and then 4 minus 2 is 2 here, right? And then 33 minus 8 is going to be 25, right? Then I have 1 1 1 and 4. So now this matrix is equivalent to the top matrix. Now I have to eliminate minus 5 from this equation. So what I'll do is I'll take the second equation and I'll subtract it from the third equation. So what I'll have is 0, and then this minus 5 plus 5 is going to be 0, minus 5, and then minus 2, that will be equal to minus 7, and then minus 10, and then minus 25 is going to be minus 35, correct? And then I am going to have 0, minus 5, 2, 25, and then I have 1, 1, 1, and 4. Correct. So this matrix is equivalent to the above two matrices. Now here the last equation is minus 7z is equal to minus 35. So z will be equal to 5. So that's my answer. Now if I substitute this in the second equation over here, this will be minus 5y plus twice of z, which is 5, is equal to 25, right? So minus 5y is equal to 25 minus 10, that is 15, right? So y is equal to minus 3, correct? So I have got one answer, I have got the second answer. Now if I take these two and put it in the first equation, so I have got x plus y, so it is minus 3, plus z, which is going to be equal to 5, correct? So x plus y plus z is equal to 4, right? So this will be equal to x is equal to, so this will be equal to 2. So the answer is 2. So I have got x equal to 2, y equal to minus 3, and z is equal to 5. So there are different ways of reducing this matrix to a upper triangular matrix, and then we are going to do this in a program in C, okay, when we deal with matrices. Okay, so this is the elimination method to solve a system of equations. So this is very simple. Okay, then there is something which you can solve, okay, easily, that is called a quadratic equation. So if the order of any variable or combination of variable is 2, then it is called quadratic equation. So there are 4 ways of solving a quadratic equation. So let's see quadratic equations. Okay, so if you have a variable or a mix of variable with a raised to power of 2, that will be called a quadratic equation. So there are various ways of solving it. One is factorization. That's the easiest one. Okay, the second one is going to be completing the squares. Okay. Okay. The third one is going to be a quadratic formula. And the fourth one is going to be a graphical method. So I can solve two equations, I can solve a second order equation graphically. Okay, so let's look at an example. Let's say that there is x square plus x minus 3 equal to 0. Now this can be split up into x square plus 3x minus 2x minus 6 equal to 0. So this can be written as x plus 3 minus 2 times of x plus 3 equal to 0, or x minus 2 x plus 3 equal to 0. So x is equal to x equal to 2, and or x is equal to minus 3. So 2 and minus 3 is the answer. Okay, so let's look at another equation. So this is one example. Let's look at another example. Okay, here I can take a equation x square plus twice of x minus 8 equal to 0. So there has to be a relationship between this and this, right? to solve this. So I can write this as x square plus 4x minus 2x minus 8 equal to 0. So I can say x plus 4 minus 2 into x plus 4 equal to 0. So x minus 2 x plus 4 equal to 0. So x is equal to 2 or minus 4. Correct? Okay. So let's look at another equation. Let's say x square minus 6x plus 9 equal to 0. So again, there has to be some relationship between here, which you will know by observation, right? So I can say x square. Can I do minus 3x plus 9 equal to 0? So x into x minus 3 into x minus 3 equal to 0. And then you have x minus 3 whole square equal to 0. So x has two roots. One is 3, another one is 3. Okay, so there is another way of doing this, is if you can express this as a square plus twice of ab plus b square. So let's see. Okay, so if you have, so in this case this is x square minus, so it is going to be plus twice of ab. Okay, a b, sorry, so a can be 1, right? So 2 times of x times of minus 3 plus minus 3 square, which is going to be 9. Okay, so then it is going to be a plus b whole square. So this will be equal to x minus 3 whole square. So that's the answer. Okay, so this is completing the squares. Okay, so now let's look at another example. So this will keep becoming difficult, right? So let's say I have got 3x square minus 11x minus 4 equal to 0. Now you don't know how to handle now the relationship between three numbers. When it's 3 minus 11 and minus 4, right? You can still do it. Okay, you can still do it. You can say 3x square minus 12x plus x minus 4, isn't it? Plus x minus 4 equal to 0. So 3x is common. So you have x minus 4 plus 1 into x minus 4 equal to 0, or 3x plus 1 x minus 4 equal to 0, right? So the answer is going to be x is equal to 4 and x equal to minus 1 by 3, isn't it? Yeah. Now I can solve this with a quadratic formula also. So that is, you have expressed this is ax square plus bx plus c. So in this case, a is equal to 3, b is equal to minus 11, isn't it? And c is equal to minus 4. So now the answer is going to be x is equal to minus b plus minus root of b square minus 4ac divided by twice of a. So let's write that. So minus b is 11. Okay, plus minus root of b square 121 minus 4ac. Okay, 4 4 16, 48. Okay, so divided by twice of a, which is going to be 6. isn't it? Minus b plus minus. Okay, so 21 minus 48. Okay, 121 minus 48. So 11, 3, isn't it? And then this will be 11, 4, 7, 73. So this doesn't look right. Where did I do a mistake? Okay, sorry about the mix-up. Okay, so 4ac. So minus 4ac would be plus 48, right? So now this will be equal to 11 plus minus root of 169 would be 13 by 6. So the answer is x. 11 minus 13 is minus 2 by 6. That's one answer. And then 11 plus 13 is 24 by 6. That's another answer. So basically this would be minus 1 by 3 and then 4. So this is the same as by the factorization. So this is the same answer. So quadratic formula will anyways gonna work, right? So if you are not able to factorize it, then you apply the quadratic formula. So that's very simple. Okay, so let's go ahead and look at log, right? So the next thing is logarithms. Okay, let's cross that. Okay, so in case of log, there are certain so if I have y is equal to a raised to x, then I can say log of a, log to the base a of y is going to be equal to x. Okay, then if I have log of x y, then this can be presented as log of x plus log of y. And similarly, if I have log of x by y, this will be written as log of x okay, log of x minus log of y. Okay, so this is about logarithms. Then there is something called power series. Now we are going to talk about this Taylor-Maclaurin power series later on. But first, just for now, I will say if e is e raised to x, it can be expressed as 1 plus x square by 2 factorial plus x raised to cube by 3 factorial plus and so on, right? So that's the expansion of power series. Now, the last topic here in this basics is going to be not the last but one, trigonometry. Okay, now in this case it's very simple. If I have a right angle triangle and I have the perpendicular in the base, then P by H will be sine theta, and then I have B by H, that's going to be equal to cos theta, correct? So that's the definition. And then you have got P square plus B square is equal to H square. This is your Pythagoras theorem, which means that I will have P by H square plus P by B square, P by H square plus B by H square, plus B by H square is equal to 1. Or I will have sine square theta plus cos square theta equal to 1. Okay, so this is one which I have to remember. So this is 1. Okay, so having said that, then I should know Euler's representation. I can say e raised to j theta can be written as cos theta plus j sine theta. Then e raised to minus j theta can be written as cos theta minus j sine theta. So using these two equations, I can also write cos theta is equal to e raised to j theta plus e raised to minus j theta by 2, and then sine theta is equal to e raised to j theta minus e raised to minus j theta divided by twice of j. Okay, and if I was to look at equivalent as sine hyperbolic theta, that will be e raised to theta minus e raised to, sorry, not j theta, twice of j. So this will be e raised to theta minus e raised to minus theta by 2. And cos hyperbolic theta is going to be e raised to theta plus e raised to minus theta by 2. Okay, so these are the basic Euler's identities, right? So having said that, right, so we have this thing and we have these. Okay, so now with this, let's progress to some other relationships in trigonometry. Okay, let's say if I want to say sine 2 theta is equal to 2 sine theta cos theta. Right, I can take RHS and prove it to be same as LHS. So I can say this is same as e raised to j theta minus e raised to minus j theta divided by twice of j into e raised to j theta plus e raised to minus j theta divided by 2. Correct? So if I was to apply this, at the bottom I'll have 2j, and here it will be e raised to j theta into e raised to j theta. So it will be e raised to j twice of theta, and then I will have plus 1, and then I have minus 1. So it will be raised to 0, right? Plus 1 minus 1, and then I would have here minus e raised to minus j twice of theta. So this would be equal to e raised to j twice of theta minus e raised to minus j twice of theta divided by twice of j, which is nothing but sine of 2 theta. So I have proven. So the third thing which I have here is sine 2 theta is equal to 2 sine theta cos theta. Simple. What about cos 2 theta? Okay, so fourth one is going to be cos 2 theta is equal to 2 cos square theta minus 1. So how would I prove that? Right, so it's very simple. Okay, I will take cos 2 theta, so I can write cos 2 theta is equal to e raised to j twice of theta plus e raised to minus j twice of theta. Okay, I will do a plus 2 and a minus 2 divided by 2, right? So in this case, this can be written as a square plus b square plus twice of ab, right? So a plus b whole square, isn't it? So this can be written as let's see. Hmm. Okay. So this can be written as e raised to j theta plus e raised to minus j theta whole square. divided by 2, okay, minus 1. So this can be written as twice of e raised to j theta plus e raised to minus j theta divided by 2 square, right? So now this becomes 4, right? Comes inside bracket minus 1. So this is going to be twice of cos square theta minus 1. So cos 2 theta is 2 cos square theta minus 1, right? So now I can, okay, so I can write this as twice angles, right? So that means cos square theta is equal to 1 plus cos 2 theta by 2, correct? So sin 2 theta is 2 sin theta cos theta. Cos 2 theta is 2 cos square theta minus 1, or in terms of twice angle, cos square theta is equal to 1 plus 2 theta. Okay, so next is sine square theta is equal to 1 minus cos square theta. So it will be 1 minus 1 plus cos 2 theta by 2, right? So it will be 2 minus 1 is 1 minus cos 2 theta by 2 sine square theta, 1 minus cos 2 theta by 2. So then I have represented as twice angles, right? Okay, so now there's one more relation in trigonometry which is important, right? So that is, I have to see what is sine of a plus b is equal to sine a cos b plus cos a sine b. And I know that sine of a is equal to e raised to ja minus e raised to minus ja by twice of j, and I know that cos of b is equal to e raised to jb plus e raised to minus jb by 2. Then I know cos of a is equal to e raised to ja plus e raised to minus ja by 2. Then I can say sine of b is equal to e raised to jb minus e raised to minus jb by 2. Okay, so let's do the multiplication and add it. So I have sine a cos b as e raised to j a plus b, okay, plus e raised to e raised to j a minus b, okay, minus e raised to minus j a minus b plus e raised to, sorry about that, plus e raised to, so I'm not left with space, minus j a plus b, right? This whole thing is multiplied, so this is 4j. Okay, similarly I have got cos a sine b. This will be e raised to j a plus b minus e raised to j a minus b plus e raised to minus j a minus b plus e raised to minus j a plus b by 4j. So this is 4j. So now sine a cos b plus cos a sine b is going to be, this cancels with that, this cancels with that, then I'm left with e raised to so I'm left with e raised to j a plus b plus e raised to plus the last term here on multiplication is going to be a negative term, isn't it? So this will be a minus number and this will be a minus number. So here there will be a minus sign. Mistake. Minus e raised to j a minus a plus b, and this is 2 times appearing, divided by 4j. So this is equivalent to e raised to j a plus b minus e raised to minus j a plus b by twice of j. So which will be equal to sine of a plus b. So I have proven that sine of a plus b is equal to sine a cos b plus cos a sine b. Now I have to one more thing to prove is sine of minus a would be equal to e raised to minus ja minus e raised to ja by twice of j, which will be equal to minus of sine of minus of sine of a. So sine of minus a is minus sine of a. What about cos? Cos of minus a would be equal to cos of a. Okay, so that means that if I have, so I have one of them as this, then I can say sine of a minus b is equal to sine a cos b minus cos a sine b. So that's the second thing which I have derived. Now let's look at cos of a plus b. So that is going to be cos of a plus b is cos a cos b minus sine a sine b. And I can prove similarly by substituting like this. I can prove this. Right. And then I have got cos of a minus b is going to be cos a cos b plus, because it is minus b, right, sine a sine b. Okay, so these 4 things are proven now. And the last thing is if I can combine them. Okay, so if I was to combine these two, then I would say cos of a plus b plus cos of a minus b is going to be equal to twice of cos a cos b. And then I can say cos of a plus b minus cos of a minus b, then this is going to be equal to minus 2 sine a sine b. Okay, so this is a derivation from these two. And then the top two, if I combine, then I would have sine of a plus b plus sine of a minus b. Okay, so what do we have? I would have sine a cos b twice of sine a cos b. Cos of a plus b plus cos of a minus b is cos twice of cos a cos b. Cos of a plus b minus cos of a minus b is minus twice a sine b, sine a sine b, and then sine of a plus b plus sine of a minus b is twice of sine a cos b, and then I have sine of a plus b minus sine of a minus b is twice of cos b, cos a, cos b, cos a sine b, sorry. Sine b. Am I right? The second term survives. Cos a sine b. Right. So that's another. So basically this is all what trigonometry is about. Okay. The next thing I'm going to talk about is differentiation and integration. So we will do some standard differentiations and integrations. Okay. So differentiation. Okay. So if I put something on that, that would be same as du by dx. Okay. So if I have this, it will be dv by dx. So this is as per the convention. So if I have cu dash, so this will be cu dash. So this is the first thing. Okay, second thing is if I have u plus v differentiation with respect to f, you can do u differentiated to x and then v differentiated to x. Third, if you have u and v differentiated to this, then it will be u v plus u v. Fourth, if you have u divided by v, then you have u dash v minus v dash u divided by v square. That's there. Okay, the final thing is I can say fifth thing is du by dx can be written as du by dy and then dy by dx. That's very simple. Now with this basic thing out of the way, let's look at some of the differentiations, and then everything would be just applying these differentiations to all the terms in an expression. So let's say I have x raised to n derivative, that will be n times of x raised to n minus 1. Seventh, I have e raised to x, this it will be same as e raised to x. Eighth, if I have e raised to ax, this it will be same as e raised to z. So I'll apply this formula. So it will be e raised to ax, then ax. Okay, so this will be that. 9. If I have sine x, so this can be written as e raised to jx minus e raised to minus jx divided by twice of j. So this would be same as j e raised to jx plus j e raised to minus jx divided by twice of j. So this j would cancel. So I have e raised to jx plus e raised to minus jx by 2, which is same as cos of x. Okay, so that is that. Then I have got cos of x derivative. So this is e raised to jx plus e raised to minus jx by 2 derivative. So this will be equal to j e raised to jx minus j e raised to minus jx by 2. So this is equal to minus of sine x. Okay, 11. Okay, so we have done that. Let's look at the okay, So if I have ln of x, isn't it? So if I have ln x, derivative is going to be 1 by x, right? Then 12 I can have. So if that is there, now let's look at tan of x derivative. So this can be written as sine of x by cos of x derivative. So then let's say cos x equal to z. So in this case sine x dx equal to dz. Okay, first term into okay, so let's not do that. Let's just apply that rule. So that will be u derivative u. So sine derivative is going to be cos. Sorry, cos of x, and then v, which is cos of x, minus u as is, and derivative of cos of x is going to be minus. So sine of x divided by cos square x. So this would be equal to 1 by cos square x, which is equal to sec square x. So derivative of 10x is equal to sec square. Similarly, I can have cot of x. This would be same as cos x by sine x derivative. So in this case, u cos of derivative cos x is minus sine x, then sine x minus of cos of x and cos of x divided by sine square of x. So this is equal to minus cosec square x. So that's that. 14. Okay, so let's say log to the base e of a of x derivative, it is going to be log a to e divided by x. Okay, now 15. Let's say sine inverse of x derivative. Okay, so sine inverse of x. Okay, so I can write sine inverse of x equal to theta. Then I have got x equal to sine theta. So dx is equal to cos theta d theta. Okay, so I have d theta by dx would be equal to 1 over cos theta, right? So the answer of this is going to be 1. So derivative is equal to 1, and then d theta by dx, okay, will be equal to sec. Am I right? Sec theta. So 1 over cos theta then. Okay, so this can be represented as, so sine theta is x. So root of 1 minus sine square theta, that is x square. So derivative of, let's repeat it, sine inverse of x derivative is going to be equal to 1 over square root of 1 minus x square. Okay, 16. Okay, how about cos inverse of x? Then this will be minus root of 1 minus x square. That's very simple, isn't it? Okay, How about tan inverse? Tan inverse of x. Okay, so have we covered that? Okay, so let's say this. Okay, okay, so that means tan inverse of x equal to theta or x equal to tan theta. So dx equal to, so we have done 10x, right? Sec square theta. Dx equal to sec square theta d theta, correct? And then d theta by dx is equal to 1 over 1 over sec square theta, right? So this integral will be 1 over sec square theta, which can be written as 1 plus tan square theta. So this can be written as 1 plus x square, correct? Okay, and similarly I have got 18 here. I have cot inverse of x derivative, which will be again theta, and this will be cot theta minus cosec square theta. So answer will be 1 plus cot square theta, so it will be minus 1 plus x square. Okay, so this way we have the fundamental differential derivatives, right? Then I can do the differentiation now, right, of any expression. Similarly, let's look for integration. Okay, so for integration, if I have got integration by, okay, if I want to integrate this, okay, so then first term into integral of second term, which will be this, minus integral of derivative of first term, integral of second term would be this plus c, and c would be a constant, right, because the lower level of integral is not known, right? So this is simple. Then let's look at the second one, is integral x raised to n dx. This will be x raised to n plus 1 by n plus 1 plus c. So for example, if you have x square integral dx, so this will be x cubed by 3 plus c. Okay, so that's the example. Third, if I have integral 1 over x dx, so we know already that this is going to be ln of x plus c. Okay, fourth one, if I have integral e raised to ax dx, then I have e raised to ax by a plus c, correct? Then if I have integral of sine of x dx, then it will be minus cos of x plus c. Then, so this is from the differentiation, I'm just doing the inverse of that. Cos of x dx, that will be equal to sine of x plus c. Then seventh one, if I have integral of tan of x dx, so this can be represented as sine by cos, right? Sine x by cos x dx, and let's say cos x equal to z, then minus sine x dx is equal to dz. So d, am I right? Yes, so I would have sine of x by z dz divided by minus sine of x. So this will cancel, so this will become minus log of sine of x plus c. So that's very simple, right? Similarly, if I have integral cot of x dx, then I would have that as cos x by sine x dx. Then sine x is equal to z, so cos x dx equal to dz. Then I would have integral cos of x by z dz by cos of x. Then this will be log of z, which will be sine of x plus c. So that's simple. The next one is, I'm not going to prove this one, this is more involved. Sec of x dx is equal to log of sec of x plus tan of x plus c. Then I have got integral cosec dx. This will be equal to log of cosec x minus cot x minus cot x plus c. Okay, 11th one. Okay, the 11th one is integral 1 over x square plus a square dx. Now let's say x is equal to a tan theta. So then dx is equal to a sec square theta d theta. Correct? So this can be written as 1 over x square. So this is going to be a square. 1 plus tan square theta is equal to sec square theta. And then I have dx replaced as a sec square theta d theta. So that cancels out. So integral 1 over a theta plus c. So 1 over a tan inverse of x by a plus c. Okay, so that is 11. 12. Integral of 1 over square root of a square minus x square dx. Then substitute x is equal to a sine theta. So what you have is, this would be equal to 1 over a times, so 1 minus sine square theta is cos theta, and then you have dx is equal to a cos theta d theta. So then you can represent this with a cos theta d theta. Then you are left with theta plus c, and then theta is equal to sine inverse of x by a plus c. So that's done. Let's look at the 13th one. Okay, so I'm about to finish on integration. Some more are left, so let's just do them. Okay, so let's say if I want to do an integral of 1 over root of x square minus a square, if it is of this form, then I can do x equal to a cos, x is equal to a cos hyperbolic theta. Okay, so dx is equal to a sine hyperbolic theta d theta. So then what I have is cos square theta. So for cos hyperbolic, cos hyperbolic square theta minus sine hyperbolic square theta equal to 1. Right, so I have cos square minus 1, so that will be sine square. So it will be a sine hyperbolic theta. This will be a sine hyperbolic theta d theta. So the answer would be theta plus c, which will be cos hyperbolic inverse of x by a plus c. Okay, similarly I have integral 1 over minus of, right? Okay, 1 over x square plus a square dx. So let's say x is equal to a sine hyperbolic theta. So dx is equal to a cos hyperbolic theta, right? And then the integral is 1 over root of a cos square plus a. No, a sine square plus a. So sine square plus 1 is cos square. So this will be a square cos hyperbolic square theta, and then this will be a cos hyperbolic theta d theta. So this would cancel out. The answer is theta plus c, where theta is going to be sine hyperbolic inverse of x by a plus c. Okay, so this is that. Then okay, I want to look at integral of sine square theta, sine square x dx. This can be written as integral of 1 minus cos 2x by 2 dx, which would be equal to half of x minus of cos is integral is sine of x plus c. Am I right? Right. Next is 16th, cos square x dx. So this can be written as 1 plus cos 2x by 2 dx, which is same as half of x. Cos is minus sine. This should be plus, isn't it? Cos is sine, right? Okay, so here plus 1 by 4 times of sine twice of x plus c. Okay, let's look at the 17th one, which is integral of tan square x dx. This can be written as 1 plus tan square theta is sec square theta dx. So then this is equal to sec square is tan x and 1 is this plus c. Similarly, I have got integral of cot square x. 1 plus cot square x is equal to minus cosec square x. Okay, so this can be written as 1 plus cot square x is equal to minus cosec square x. Minus cosec square x minus 1 dx. This will be cot x 1 plus cot square x is equal to minus cosec square x. So let's write is 1 plus cot square x equal to minus cosec square x. So it will be minus cosec square minus 1. So minus cosec is cot of x minus x plus c. Okay, then the 19th one is going to be integral of ln of x dx. So this can be done by parts. First term as ln of x, integral of 1 is x minus integral of derivative of first term is this, integral of second term is this and this. So this becomes ln of x dot x minus x plus c. Okay, then if I was to do 20th, which is integral of e raised to ax sine of bx dx, so I can write this integral as first term into integral of second term. Sine of bx integral is going to be minus cos. So minus cos of bx by b. First term into integral of second term minus integral of derivative of first term, which is going to be a e raised to ax. The integral of second term is going to be cos of bx by b, and minus will become plus, isn't it? Dx minus integral of derivative of first, correct. So now I'm going to do the second part by b cos of bx. The second part will be a by b common, first term into integral of second term minus integral of derivative of first term integral of second term bx dx. Okay, so now I can take this term on the left hand side. I would have a square by b square, so it will be a square plus b square by a square times of integral of, sorry, by b square, sorry, e raised to ax sine of bx dx would be equal to b square is common, so let's take it on the right hand side, multiply by b square. Okay, so first term multiplied by b square would be minus b e raised to ax cos of bx. Okay, and the second term is going to be plus a e raised to ax sine of bx. Okay, so simple. Integral of e raised to x sine of bx dx is equal to 1 over a square plus b square times of a e raised to a, no, e raised to ax is common, a sine of bx minus b cos of bx. Correct? Okay, so this is done. 21, let's do integral e raised to ax cos of bx dx. So in this case, let's do by parts. So this is equal to first term into integral of second term would be sine of bx by b minus integral of derivative of first term integral of second term dx. Okay, so let's integrate by parts again. Sine of bx. So in this case, first term, so a by b is common, first term into integral of second term. Okay, so this will become minus cos of bx by b minus integral of derivative of first term, so a by b factor will come e raised to ax, integral of this, so it will become plus cos of bx dx. Now take this term on the left hand side. I would have a square plus b square times of integral of b square common, multiply both sides, right? Integral e raised to ax cos of bx dx would be equal to b times of b times of e raised to ax sine of bx, okay, plus a times of e raised to ax cos of bx. So this will be equal to e raised to, so integral, so let's just write this out. So then integral e raised to ax cos of bx dx would be equal to 1 over a square plus b square e raised to ax common. I have got b sine of bx plus a cos of bx, right? So that's the answer. So with this, I have done all the basic entities of integration. Okay, so now what I'll do is I would expand upon this. So if you see the elimination part, right? So we were dealing with system of equations. So I will go into now the matrices and then augmented matrices, and then how do you minimize that using various techniques. In the next session, we will start with the matrices, right? And then we will look at the system of equations and solve it. So like this, I'm going to build upon all the basics to advanced engineering mathematics, right? So I'm going to cover quite a bit of sessions in this engineering mathematics. Thanks a lot. Thank you.